Hello and welcome. Today we're going to take a look at breaking down monomials by factoring out a given factor. At the end, I'm going to introduce to you the process of factoring binomials. Let's go ahead and begin by recalling how we find the greatest common factor. Step 1, I'm going to go ahead and factor down my 42. I get 7 times 6. 6 factors down into 3 times 2. Now that all of these numbers are prime, I ignore anything that's not at the end of a branch. And my prime factorization of 42 is 2 times 3 times 7. Now in this term I also have an x to the 5th. I'm going to go ahead and write x to the 5th. For 36, when I factor it, I can break it down into 6 times 6, which breaks down into 3 times 2 and 3 times 2. Ignoring anything that's not at the end of the branch, I see that my prime factorization of 36 is 2 times 2 times 3 times 3. I'm writing them in order from least to greatest. I also have an x to the 3rd power. Now what they have in common, they have a 2, they have a 3, and they have some x's in common. 36 has 3 x's, where 42 has 5 x's. Since 5 is greater than 3, they only have x to the 3rd in common. So my greatest common factor of the two terms is 6, because 2 times 3 is 6, and x to the 3rd. Now, we're going to rewrite monomials by factoring. So what I would like to do is factor in 8x squared y out of negative 16 x to the 4th y to the 3rd. What this means is that we are going to rewrite our negative 16 x to the 4th y as 8x squared y times something. So we are going to go backwards here. Normally we say, okay, this times something gives me my 16 x to the 4th y. But now we're going to undo that and kind of work backwards. How we can do this is to take the 16 x to the 4th y and divide it by 8x squared y. Whatever you get from that division is what belongs in your parentheses. So negative 16 and 8 reduces to a negative 2 and a 1. So I have negative 2x to the 4th y to the 3rd over 1x to the 2nd y. I may reduce the x's by subtracting the exponents. I have 4 on top and 2 on the bottom. So 4 minus 2 is 2, and since there are more on the top, my x to the 2nd power remains on the top. And all of my x's in the denominator are gone. Reducing my y's, I have 3 on top and 1 on the bottom. So subtracting 3 minus 1, I get 2. And again, since there are more on top, my y's remain on the top, and the y's in the denominator cancel. So all that's left on the bottom is a 1. We can write over 1 or not, since it's unnecessary. So what we just found is that if we factor 8x squared y out of our negative 16x to the 4th y to the 3rd, we will get negative 2x squared y squared. Or if you multiply 8x squared y by negative 2x squared y squared, if you multiply those two together, then this will give you your original term of negative 16 x to the 4th y to the 3rd. Let's test it out real quick just to make sure that we didn't make any mistakes. So I've got 8 x to the 2nd y times negative 2 x to the 2nd y to the 2nd. 8 times negative 2 multiplies to a negative 16. X times x. When I'm multiplying, I add the exponents, and I'll get an x to the 4th power. Multiplying my y's, I add the exponents, and I get y to the 3rd power. which is our original term, so we factored correctly. I'm going to do this a couple more times and then ask you to practice on your own. So to factor out a 9x squared y from my original 18x to the 5th y to the 7th, I am going to divide the original by my 9x to the 2nd, y to the 2nd. My 18 and my 9 reduce to a 2 and a 1. My x to the 5th and my x to the 2nd reduce when I subtract exponents to x to the 3rd power. Since there are more x's on top, my x's in the denominator go away completely. So I've got 2x to the 3rd on the top over 1 on the bottom. For my y's, when I reduce, there are more y's on top. 7 minus 2 is 5, so I have y to the 5th power on top, which is just 2x to the 3rd, y to the 5th. So what we just found is that if we multiply these two things together, we will end up with our original term. Let's try it out to make sure we didn't make a mistake. 9 times 2 is 18. Multiplying my x's, I add the exponents to get x to the 5th. Multiplying my y's, I add the exponents to get y to the 7th power. And that is what we started with, so we did this correctly. Now below, I'm factoring out negative 2x to the 5th y from my 24x to the 9th y to the 9th power. So I take my 24 term and I divide it by my negative 2x to the 5th y to the 2nd. My 24 and negative 2 reduce to a 12 and a negative 1. So I have 12 on top and negative 1 on the bottom. Now my x's reduce. I have x to the 9th on top, so my x's will remain on the top when I reduce. And 9 minus 5 is 4, so my new exponent is 4, and all the x's on the bottom go away. When I reduce my y's, I have more y's on the top, so they will remain on the top. Y to the 9th and y to the 2nd, when I subtract the exponents, I get y to the 7th in the numerator, and all of my y's in the denominator go away. So now how I can rewrite this, instead of my negative on the bottom, I can divide and make my 12 on top negative, and write this without the denominator. So I have negative 12, x to the 4th, y to the 7th. When I multiply these two together, I should get what we started with. Negative 2 times 12 is a positive 24. Multiplying my x's, I add the exponents to get x to the 9th. Multiplying my y's, I add the exponents to get y to the 9th. And that is what we started with on the left. Last one down below, I'm going to divide by negative 8, x to the 7th, y to the 2nd, by 4, x to the 4th, y. Reducing my negative 8 and 4 to negative 2 and 1, I have negative 2 on the top of my fraction and 1 on the bottom. Subtracting the exponents on my x's, I have more x's on top, so they will remain on the top. 7 minus 4 is 3, so my new exponent is 3, and all the x's in the denominator go away. Reducing my y's, I have more on top, so they will remain on the top. I have y to the 2nd over y to the 1st power. 2 minus 1 is 1, so I have y to the 1st in my numerator. So what we have is negative 2 x to the 3rd times y to the 1st power, or just y. So what we have found is that when I multiply these two things together, I will obtain my original. 4 times negative 2 is negative 8. X to the 4th times x to the 3rd is x to the 7th when I add the exponents. And y times y is y squared when I add the exponents. Now this is our original term that we started with, so we have factored correctly. Go ahead and take a moment to pause the video and try the next two on your own. For the first, you should have a negative 4 x to the 4th. For the second, you should have negative 5 y to the 6th times z. Now I'm going to briefly introduce to you the process of factoring binomials. So what this means is we are going to take a binomial or a polynomial with two terms, for example, 9x plus 3, and break it down into two pieces that you may multiply to obtain the original. So step 1, I'm going to identify any greatest common factor between the two terms. So for example, here with 9 and 3, the greatest common factor of both of those terms is a 3. I can divide 9x by 3 and I can divide 3 by 3. Step 2, I am going to factor out this greatest common factor by dividing each term by it. So first I'll divide 9x by 3 and I get 3x. Then I'll divide 3 by 3 and I get a positive 1 or plus 1. So what I've done is I've taken out that greatest common factor of 3. Now how we notate having factored it out is we put it on the outside of parentheses. Basically, we are undoing our distribution. If you were to multiply these back together, you would end up with your original 9x plus 3. Let's go ahead and try it out. 3 times 3x is 9x. 3 times positive 1 is a positive 3. So all we did is we undid our distribution by taking out the 3. When you put the 3 back in, you will obtain what you had in the beginning. Identifying my greatest common factor between 6x and 3. I find that my greatest common factor is, as it was above, a 3. So I am going to factor out my 3. First, I'll write the 3 on the outside of parentheses. And then I divide each term by 3. 6x divided by 3 gives me 2x. 3 divided by 3 gives me a positive 1. So we took out the 3 by dividing everything by it. Now to check your answer, we can distribute it back in to see if what we did was correct. 3 times 2 is 6x. 3 times 1 is a positive 3. That matches what we had in the beginning, so we did our process correctly. Below to the left, I'm going to identify my greatest common factor. Looking at the two terms, 10 and 15, I can see that my greatest common factor is a 5. So I write my 5 on the outside of parentheses, and I divide everything on the inside by 5. 10 divided by 5 is 2x. Negative 15 divided by 5 is a negative 3. To check my answer, I may distribute my 5 back in. 5 times 2 is 10x, and 5 times negative 3 is a negative 15. So that does match what we had in the beginning. So we did factor correctly. The greatest common factor of 18 and negative 45 is a 9. So I'm going to go ahead and factor out my 9 by writing the 9 on the outside of parentheses. 18w divided by 9 is 2w. Negative 45 divided by 9 is a negative 5. So this is the factored form of my original binomial. I can distribute my 9 back in to get 18w minus 45. And since that matches our original, we have factored correctly. Go ahead and take a moment to pause the video and try the next 4 on your own. For the first, you should have factored out a greatest common factor of 4, leaving you with 2k minus 3 inside the parentheses. For the second, to the right, you should have found a greatest common factor of 3, leaving you with 3y minus 5 in the parentheses. The bottom left, you should have found a greatest common factor of 4, leaving you with 4x plus 3 inside your parentheses. And last, you should have found a greatest common factor of 8, leaving you with a 4w minus 3 in parentheses. Thanks for watching. Hope you enjoy the rest of your day.